Welcome to, well, this is the last lecture on Chapter 1. I'll be talking about material that's currently in Section 1.1 of the textbook. It's on translating compound statements. Although, as I mentioned earlier, I might change the order of this in the textbook. This might end up being stuff that's in 1.2. It doesn't matter. Uh, Everything that's in Chapter 1 I talk about in these videos. The only thing that's different is the order, but it's all in Chapter 1. Okay, the topic is translating compound statements. Where we left off last time was translating just the statements, the statement operators themselves. So how do you translate the symbol for conjunction, a disjunction, a conditional, that is putting together two atomic statements. Now we're just going to practice that and get better at it. And that'll be basically what we're doing in the chapter. We're going to end up translating arguments, but an argument is just a set of statements. So we translate an argument simply by translating the statements, the premises and conclusion that make it up. Okay, so here's a compound statement. If Sarah doesn't come to the party, then we won't need the vegetarian burgers. Step one, when you are translating from natural language into the formal notation, is to identify the atomic statements that are used in the compound statement. Here we have two. We have Sarah comes to the party, and we will need the vegetarian burgers. Now, the important thing to notice is that in the original sentence, both of these are negated. We have Sarah doesn't come to the party, and we have we won't need the vegetarian burgers. But remember, negation is an operator. So when we're looking for the atomic statement, we want the unnegated version. We want the version that doesn't have the not in it, or the it is false, or the NT. Okay, so that's why the atomic statements here are Sarah comes to the party, we will need the vegetarian burgers. Okay, so that's step one. Step two is rewrite the original sentence, only plug in the variables, the letters, in this case S and V, for the sentences that they represent, and leave everything else the same. And you get something like this. If not S, then not V. So I left the if and the then. I left the period and the comma. I had to do something with the negations that were in the middle here, and I put those as not S and not V. But this is basically what you get when you plug S and V in for the sentences they represent. Now, so this is kind of halfway there. We're halfway between the pure formal notation and the original English. Now we just need to get the rest of the way there. We need to translate the logical statements now. The if, the thens, the nots. Well, that's going to be easy. Not S and not V, those are just going to be tildes. We'll have a tilde S and a tilde V. The if and the then, that's going to be a conditional. So we're going to have a horseshoe. And now the question is, which one of these is the antecedent and which one is the consequent? Remember, we can't just go in order. We can't just assume that the thing that shows up first is going to be the antecedent and the one that shows up second is going to be the consequent. We have to look for the code words. Well, it's coded with if, then. It's not an only if, it's an if. And remember, the rule is the thing following if is the antecedent. So not S is the antecedent. And antecedents go on the left. So we're going to have tilde S, horseshoe, tilde V. Okay, not S, not V is tilde V. It's a conditional. This is the antecedent because it's the thing that's following the if. The thing following then is the consequent, and that's going on the right. Okay, so this is how you would do it. On the first exam, there will be questions like this. I'll give you a statement, a compound statement, and say translate this into formal notation. this is exactly how you do it. First, you identify the atomic statements, you give them their own letter, you rewrite the original by plugging in the atomic statements, and then you move from this kind of halfway thing into the full logical symbolism here. Okay, let's do another example. The sentence is, I'll buy an Xbox 360 and either a PSP or Nintendo DS. Okay, step one, what are the atomic statements? Well, I'll buy an Xbox 360, I'll buy a PSP, and I'll buy a Nintendo DS. And those are the letters that I'm assigning to those atomic statements. The next thing I'm going to do is I'm going to rewrite the original, but just plug in the letters for the statements they stand for. And I'm going to leave everything else there. X, comma, and either P or N is what I'm left with here. Now, we've got 3 atomic statements and we've got 2 operators. We've got a conjunction, an and we've got a disjunction, either or. And I'm going to be talking about this for a few minutes, but there's 2 ways this could go down, right? And this is why the commas are going to be important, because the commas in English represent major logical breaks in a sentence. And so where the comma is tells you where the main operator is. Okay, and this is what do I mean by main operator? This is what I'm going to be talking about for the next few minutes. So we're left with X and either P or N. Well, the comma is next to the and, so that's telling me that this conjunction is the main operator. This whole sentence is a conjunction. The first conjunct is X. The second conjunct is this disjunction here. So what I'm going to do is I'm going to put parentheses around this to make it a little clearer. This is saying X and this is the second conjunct. Well, the second conjunct is itself a compound statement. It's a negation. Okay. Now when I translate this one step more, okay, this and is going to be a dot. This either or is going to be P wedge N, and I'll get this. X and P or N. Okay. Now there are a few things I did here that might not be 100% clear, and that's why I'm going to back up a minute. Let's do the same thing again, only let's imagine the comma was not there. I'll buy an Xbox 360 and a PSP or Nintendo DS. And I'm going to use the same atomic statements. Now when I plug these in, I get X and P or N. Now this is ambiguous. There's 2 different ways you could interpret this sentence here. Okay? You could say, and this is the first interpretation, this whole thing is a disjunction. Maybe the disjunction is the main operator. The first disjunct is this conjunction X and P, and the second disjunct is the statement N. The other possibility is that the main operator is the and. The whole statement is a conjunction. The first conjunct is X. The second conjunct is the disjunction P or N. Okay? Now these mean different things, right? Now intuitively you can just look at it, right? What this means is, this means I've got 2 options I'm considering. Option 1, I'm going to get an Xbox and a PSP. Or the other thing I might do is just get a Nintendo DS, right? I won't have a console at all. I'll only have a handheld video game system, right? This is different. What this is saying is that, okay, 2 things are going to happen. I'm going to get an Xbox. In addition to that, I'm going to get either a PSP or a Nintendo DS, right? So I'm going to have a console and I'm going to have a handheld. I just don't know which handheld it is. So you can see these are different scenarios, right? If this statement is what I meant, then no matter what I decide, I'm going to have a console. I'm going to have one console and one handheld. This is saying something different. This is saying, well, look, one option is I'll have a console and this handheld, or the other option is I won't have a console at all. I'll just have the Nintendo DS. Okay, so it's ambiguous. It could mean two different things. This is similar to the ambiguity you would get with this statement, 5 times 4 plus 1. There's two different things this could mean. Let me go ahead and rewrite this up here. In the same way that this is ambiguous and could mean either of these, this statement is ambiguous and can mean either of these. It could mean either 5 times 4, which is 20, plus 1, which would be 21, or it could mean 5 times what? 5 times 4 plus 1, which is 5. So 5 times 5 would be 25. So they would evaluate to different things. This would be 25, this would be 21. Okay, in this case, the main operator would be addition. This whole thing is a sum, and the two things that are being added is this and this. Here, the main operator is multiplication. The two things that are being multiplied is this and this. Okay. Now, one way to resolve an ambiguity, okay, so this is ambiguous here. One way to resolve an ambiguity is what I've done here, is I've just used parentheses. And when I use parentheses, I'm telling you what the main operator is. The main operator is this one. This is just one of the components that I put in parentheses. Here I'm using parentheses such to indicate this is a component. This is the main operator. Now in arithmetic, you don't need parentheses. Another way you could resolve an ambiguity is you could just adopt a convention to the effect that you always evaluate, some operators before other operators, let's say. You always, you could make the convention anything you want. You always evaluate subtraction before addition, or you always evaluate division before anything else, right? In fact, in arithmetic, there is a convention that most people use, so you don't have to use parentheses if you don't want to. But you can use parentheses, which just makes it explicitly clear what the main operator is. In our class for logic, we're going to use parentheses. We're not going to use any conventions as to what order you evaluate these operators in. We're always going to use parentheses to be explicit about it. Okay? So here, I'm using parentheses to show that this is a component, this is the main operator. In this case, this is the main operator. And so this would be translated like this. If it is this way, it would be translated like that. So this statement is ambiguous between these two different interpretations. Now you might be asking yourself, or even asking me, hey Rick, this sucks. If this happened on an exam, how would I know which one to do? Well, the answer to that question is this won't happen on an exam, right? On an exam, I would do something like what happened in the first case. I would put a comma somewhere, which would indicate to you what the main operator was, right? The comma is next to the main operator. I just gave you the ambiguous one so you could kind of see what an ambiguity is and how you would resolve it with, or how you would use parentheses to indicate which way of resolving it you were going with. In practice, though, you'll always know which one is meant because I'll use a comma or some other way of disambiguating it. Okay, let's do another example. The car runs well and the motorcycle runs well, but you should be careful if you take the boat out. Okay. Step one, let's find the atomic statements, and there's going to be 4 of them. The car runs well, the motorcycle runs well, you should be careful, you take the boat out. Okay, so those are the atomic statements, and I'm going to assign these letters here to these statements. Next, I'm going to rewrite the original passage, but using these letters instead of the sentences they stand for. And I get this, C and M, but Y if B. Okay. I'm going to move this just up a little bit here. Okay. So C and M, comma, but Y if B. I'm leaving the comma here. Why? Because the comma is telling me which operator is the main operator. It's this one, the but, which is a conjunction. So I know this whole statement is a conjunction. The first conjunct is this thing, the second conjunct is this thing. So I'm going to go ahead and use parentheses now around this and around this because I know this is the main operator. Okay. Now that I know what the grouping is, what the main operator is and what the subordinate operators are, right? This is the first conjunct, this is the second conjunct. Now I'm going to do the final, well, actually I'm not. I'm going to do it in 2 steps. First, I'm going to translate the conjunctions. Those are easy. This is just a dot and this is a dot. I'm going to leave the conditional for a second. So I have C dot M and this is a dot. That's going to be this and that. Now I need to translate this conditional. Okay, so I know it's going to be a horseshoe. Question is which one is going to be on the left and which is on the right. Okay, in the formal notation, we're going to put the antecedent on the left always. Which one is the antecedent? Well, it's using if, and remember the rule is the statement following if is the antecedent. So B is the antecedent. So B is going to go on the left, then it's horseshoe, and then Y is the consequent on the right. And at this point, I don't need the comma anymore. So this is the final translation, C and M and B horseshoe Y. Okay. And so this is what you would write down as the translation of that statement. All right, next up. Either you will get a fine or you will have to do hard time if you don't pay your taxes and you don't file an extension. Okay, and again, we've got a comma there that's going to be a clue for us. So step 1, let's find the atomic statements, and there's going to be 4 of them. You will get a fine, you will do hard time, you pay your taxes, you file an extension. And I've provided capital letters as to translate those as symbols for those. Okay, let's just move that up here, give us some space. Now I'm going to rewrite the original statement, plugging those letters in, either F or H, if not T and not E. Okay, so the comma is next to this if, so this is telling me that this whole statement is a conditional. Okay, these are the components. One of these is the antecedent, one of them is the consequent. Okay, but this disjunction is one of the components and this conjunction is one of the components. Okay, so I'm going to go ahead and put parentheses. I know the if is the main operator and it's putting these 2 components together. So I'm going to do the parentheses. I'm also going to do the negations now. Not becomes tilde. So I have either F or H, if, not T and not E. Okay, now I'm going to go ahead and do translate the symbols for the disjunction and conjunction. F or H, if, not T and not E. Now I have to do the conditional. Okay, and remember, I'm going to have a horseshoe. What goes on the left? Antecedent always goes on the left. Which one's the antecedent? It's the thing following if. So this is the antecedent. It's going to go first. So it's going to be T and E, horseshoe, and then this is the consequent, F or H. And that's the final translated version of that statement. Okay. Now that we've done statements, we can do arguments. Okay. So an argument is a set of statements. So to translate an argument, all you need to do is translate the statements. You translate the premises and the conclusion. You we also have a symbol for the conclusion, which is a triple dot. So there is a little bit extra you have to do. You're going to number the premises in the conclusion, and you're going to put the triple dot symbol to indicate which one is the conclusion. But all of the hard work is translating the statements. Okay, so let's do an example. Here's an argument. Either you were at work or you were at the bar, but your office wasn't open today, therefore you were at the bar. Okay, so that's an argument. First thing I'm going to do, and this is the first step, is I'm going to number the premises and the conclusion and indicate the conclusion with a triple dot. So I'm going to turn this into this. All of the English is still the same. I haven't translated that yet. So I haven't done the individual statements yet. What I've done is indicated which ones are the premises. I've ordered them with numbers. I've also ordered the conclusion. It's always last. It's always got the highest number. Okay. And I've got the triple dot to indicate also which one is the conclusion. Okay, so now I'm just going to move that up to give myself some space. Okay, so that's the argument I'm going to translate. Step one, what are the atomic statements? Well, there's three. You were at work, you were at the bar, your office was open today. Okay, and those are the letters I'm going to use to translate them. I'm going to now plug those back into the argument, and I get this. Premise one, either W or B. Premise two, but not O. Therefore, conclusion three, B. All right, now let's translate those. This is easy. Either W or B, it's just a disjunction. It's going to be W wedge B. Okay, that's trivial. 3 is also trivial. There's no logical operators. It's just the atomic statement B, so it's just going to be B. We'll get rid of the period, but that's just going to be B. The only one that's mildly tricky is 2, so this is going to be tilde O for not O. You might think, oh, what's the but doing here? Rick said but was conjunction. Yes, but is conjunction if there's two statements there that it's putting together, if it's acting like a logic, like a statement operator. If it's just in the front of a sentence, it's not really a conjunction. I mean, it's almost like it's saying, well, here's a sentence and here's another sentence. So it's kind of, you can think of it as kind of conjunction in that way, but here's the easy thing to do. If but is the first word in a sentence, ignore it. It's not a conjunction. Okay? It's only a conjunction if it's in the middle, if it's putting two things together, something on the left and the right. Same thing with and. If and is just starting a sentence also, don't just ignore it. Okay, which means 2 is just going to be tilde O. So that's what we have. W or B, not O, therefore B. Okay. Let's do another one. A little bit more complicated, but really not too bad. If Mo slaps Larry upside the head, then Larry will slap Curly upside the head. Curly will hit Mo with a hammer only if Larry slaps him, where him is Curly, upside the head. Curly will hit Mo with a hammer unless Mo does not slap Larry upside the head. But Mo does slap Larry upside the head. Therefore, Curly will hit Mo with a hammer if Larry slaps Curly upside the head. Okay. Now, here's an interesting thing. You go through and you find the atomic statements here, and it turns out there's only 3 of them. M, Mo slaps Larry upside the head. L, Larry slaps Curly upside the head. C, Curly hits Mo with a hammer. That's it. Okay? So now let's go through and rewrite all of those statements, but plugging in those letters for those statements, and we'll do them one at a time. So I'm going to color code. First I'm doing this one. This is if M, then L. Okay. Next one. C, only if L. Next. C, okay, I didn't mention this before, but I'll mention it now. Unless, just make your life easy, translate it as a disjunction. Okay, remember that when we were talking about disjunction, either Dallas will win the Super Bowl or Buffalo will win the Super Bowl. You could also say Dallas will win the Super Bowl unless Buffalo wins the Super Bowl. Okay, just translate unless as a disjunction. It's a little bit trickier than what I just said, but don't worry about that. If you translate it as a disjunction, everyone's happy. Okay, so this will be C or not M. Okay, it's going to be a disjunction. Next one, but M. But Mo does slap Larry upside the head. Therefore, C if L. Okay, so that's the halfway point. So I'm going to rewrite this up here. When I rewrite it, now I'm going to number these things. So I'm going 1, 2, 3, 4, therefore 5. Okay. And now all we have to do is translate these things. Let's look at number 1. This is going to be easy. It's a conditional. If M, then L. M follows the if, so it's going to be M horseshoe L. M is the antecedent. Okay, so M horseshoe L. Let's look at this one. C only if L. Okay, it's a conditional, but it's with only if. Okay, what's the rule? Statement following if is the antecedent, but statement following only if is the consequent. So L is the consequent. So, and consequents go on the right. So this is going to be C horseshoe L. So we have M horseshoe L, C horseshoe L, C or not M. So C wedge tilde M. Okay. But M, that's just M. And then finally, therefore, triple dot, C if L. Okay, conditional. L follows if, so L is the antecedent, so L goes on the left. So it'll be L horseshoe C. So we get this. Okay, if M then L, M then L, C then L, C only if L, only if, thing following only if is consequent, so L is the consequent here. C or not M, C or not M, but M, it's just M. Therefore, triple dot, C if L. Thing following if is the antecedent, so L is the antecedent, other statement is the consequent. Okay, that is it. That is the end of chapter 1.